Hello and welcome everyone to today's webinar on ensuring data consistency in cloud-native applications. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. We're excited to show you how Oracle Transaction Manager for Microservices Free can simplify achieving the required level of data consistency with microservices developed in Java or TypeScript using frameworks such as Springboot, Helidon, and Node.js. If you have any questions during the webcast, please ask them in the Slack channel and we'll answer them throughout the session. The link to join is bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for webinar data consistency to reach our dedicated space for Q&A today. Today's webcast will be presented by Deepak Goel, Senior Director of Software Development, Todd Little, Chief Architect, and Brajesh Dio, Consulting Member of Technical Staff. So without further ado, I'll hand it over to Deepak.
So as Tara said that we are going to talk about this transaction manager for microservices, and here is the brief agenda that we are going to go through. First, what are the challenges in today's industry, today's application development in microservices application and data consistency? And then we would provide you an overview of the product that we are working on and is already available. And then how it simplify your application development, flexibility of the product, and then how can you get started. We plan to leave 5 to 10 minutes towards the end for any Q&A, in-person Q&A, but feel free to ask questions in the Slack channel or Zoom chat, as Tara mentioned already. So let's first talk about the challenges with microservices. We know that microservices, there are a number of microservices that make an application, and these microservices are expected to work together. A business transaction, in fact, may encompass multiple microservices, and each microservice might be updating its own data resource. That's when the challenge comes in, like when all these microservices are part of same business transaction updating their own data resource. How do you make sure that data is consistent across all these microservices? So some people actually avoid using ACID transaction for scalability, etc. But is that really is it really worth the effort there, avoiding the ACID transaction? Also, the polyglot applications, if you are developing these microservices in different programming languages, then there is no consistent framework that you can use to ensure this kind of data consistency. So let's look at what is data consistency to begin with. So let's take a very simple transaction that one is withdrawing from one bank account and depositing into the other. Now the money, where is my money? I withdraw it and I wanted to deposit into the other as part of a transfer transaction. My money was withdrawn, but it's not deposited into the targeted account. And the bank manager say that we don't have your money. It's not in the target account. So that kind of problem can happen without transactions, and that's the other primary reasons that you need data consistency for. So to avoid the financial losses, you are withdrawing, but the money doesn't show up, and you need to figure out. Also, in the supply chain kind of environment, you have an order filled, but no invoice was generated or the payment was not received. So that kind of situation can happen because of the inconsistency. Because of these inconsistency, the customer dissatisfaction can take place. You booked a seat, you made a payment, but someone else is sitting in your seat. And order thing we already talked about. Also, the legal issues might originate from these kind of inconsistency issue. So how is inconsistency handled today? There are various ways. First of all, is the manual reconciliation. So at the end of the day, end of the week, or whatever frequency you decide, you might want to just reconcile all the data source that you have and see if those are in consistent state. This is, of course, like very manually intensive process. It takes time and it's error prone to begin with, right? So it's all manual, and that causes errors. Let me call it a lot of errors here. The second way is developers build this transaction management logic in the application itself. So now the burden goes to the developers. They have to code it in that way. They have to test it in that way. It can also be very error prone. And of course, the testing complexity and all that increases. At the same time, the time and cost to market your application increases manifold. The other way of ensuring data consistency today is use one of the existing transaction managers. There are not many transaction managers which exist as of now. There are some solutions out there which are, and most of these are Java focused. Microservices are being developed in many different languages, but many of these existing ones are Java focused. And these transaction managers also do not provide the varying level of consistency. So different applications might have different requirements with respect to data consistency. It might be strong consistency requirement or eventual something else. Also, these transaction managers lack the enterprise capabilities. They don't have these availability and scalability that enterprise applications desire. Also, given that microservices are being developed in Kubernetes, they don't have native integration with Kubernetes stack as such, and not optimized for Oracle database. Yes. So there is a clear need actually for an enterprise solution to address this data consistency issue for microservices application. So before we go into the product detail, let me just talk a little bit about what transactions are and what kind of transaction protocols are out there, just to give you the context of the product that we are working on. So I think like everyone should be familiar with the transactions. Basically, we are talking about the atomic transactions, distributed transactions, global transactions, with many terminology that are in use. And here, what we say that multiple resources, either they all commit or they don't commit. And that way we can have the data in consistent state across multiple resources. So three popular protocols. XA has been out there for quite some time. It is a proven technology and best two-phase commit protocol that is known in the industry. It provides the full ACID properties. Then there is LRA. LRA provides the eventual consistency, but it lacks isolation as such. And there is some business logic that developers would have to write in order to compensate the transaction. And then the try, confirm, cancel, it provides the global consistency. But the applications have to be designed in a certain way to so that those applications are based on the reservations. So let's look a little bit more into these transaction model. XA is a two-phase commit protocols, and it provides the strongest consistency out there. And as I said, it has been there for quite some time, actually maybe 40, 50 years. They started with the mainframe era, and then moved on to the open systems as well. XA transactions maintain the ACID properties. So these transactions are atomic, these are consistent, isolated in that way, provides the isolation, and these are durable. So once committed, it's committed. The best thing about XA transaction is that these are transparent to the application. So application logic does not change. You just encapsulate the business logic that you want to be part of the transaction with some transaction demarcation APIs like transaction begin and transaction commit or rollback, and it's all taken care of. And of course, it has been out there for a long time. As I mentioned, it's widely adopted. The second one is the Saga orchestration, or this is mostly used for long-running activities and somewhat actually for loosely coupled services. So these services could be actually even in different organizations, and you want to coordinate the transaction across that. But Sagas and LRA, they provide the eventual consistency. So for a period of time, for the duration of the transaction, you might see different data set. The data set may not be consistent. In one database, the update might have gone through, but in the other, it may not have gone through, or it's still waiting for it. And whatever you see, actually, that update has been done in one of the resource, that might be rolled back eventually as well. So that kind of inconsistency can be there for the duration of the transaction. And I mentioned that completion and compensating action, these are totally left to the developer of the application. They would have to implement this business logic that the transaction managers or coordinators are going to call at the completion or compensation of this LRA. Try, confirm, cancel. This is another two-phase protocol, but I mentioned that the application have to be designed in a certain way that it allows for a reservation model. So these are this kind of protocol is good for use cases like where you are reserving a movie seat, for example. So you can mark that particular seat that is reserved. It's not committed yet in the database, but it's reserved. And in case the payment, for example, does not go through, then you can just unmark that reserved state for that particular seat, and it becomes available to other buyers, potential buyers. So compensating a failed transaction in this case is very easy. You are just putting a flag there and you are unsetting that. And that way you don't have to write the compensating logic that you were writing in the case of Sagas and LRA. So these are the three transaction protocols that we are implementing in our product. And with that, let me pass control to Todd Little, who is chief architect for the product, and he's going to go into the details of what we have actually done. Stop.
Thank you, Deepak. Can you see my screen okay?
Yes.
All right. So I'm going to talk a little bit about the product and what features it provides. So we're announcing this newly released product called Microservices, Transaction Manager for Microservices. We're also calling that MicroTx. And it provides a set of services to allow application developers to be able to leverage these various transaction models. So it supports polyglot applications, currently just supporting Java and TypeScript, with plans to support other languages in the future. It'll support a variety of different platforms. This was mentioned. So running this in the Java world, you can use Helidon, you can use WebLogic Server, you can use a number of different, like Springboot, a number of different platforms. It's designed to be deployed into Kubernetes, so it fits in with your microservices environment. And you can use a variety of different resource managers. That would be like databases, messaging systems, those sorts of things. And as well, you can make use of your existing applications. So it consists of, first, some benefits. So one of the big benefits that the MicroTx provides is that it reduces complexity for the application developer, especially in the case of XA. There's very little work other than demarcating the transaction boundaries. And as a result, since you don't have as much work for the developer, you could improve productivity. The product is based upon industry standards. So XA is a well-known standard. Sagas, or the case here that we're supporting, is Eclipse Microprofile, long-running actions. It's also a well-known standard. And try, confirm, cancel is well published in the industry. It'll also then, as I mentioned, get you to a faster time to market for your product that you're developing. And you can use existing, your existing frameworks, your existing policies. How you're actually developing your application doesn't change. So you can use all of your existing assets that you already have. So the transaction manager consists of two major components. One is the transaction coordinator itself. It's responsible for managing the state of the transaction and ensuring that all the participants are maintained and operating correctly within the transaction. And then as well, we provide a set of client libraries for each environment and programming language. And what these do is these dramatically simplify making use of the transaction coordinator. So the transaction coordinator itself is simply another microservice. It gets deployed into Kubernetes, just like your application services would do. And all the communication is done via REST at the moment. So as long as your framework can support REST APIs using something like Jersey or JAX-RS in the Java world, or if you're using Node.js or TypeScript, then using either Fetch or Axios. And as well, we provide supporting the state storage of the transactions in either Oracle database or an etcd. So an XA support in MicroTx, it's a XA compliant app in implementation. In the Java world, we support JTA. In TypeScript, we have our own set of APIs because there's no standard set of APIs for XA in TypeScript. We also use what we're calling a unique RM, a proxy approach, and I'll explain that in a minute. to help make it easier to be able to support various resource managers. As well, we're supporting some optimizations for XA. One in particular is what's called the logging last resource that allows a non-XA resource manager to participate in an XA transaction. And it's been highly optimized. So we do a number of optimizations around collapsing the commit tree if we can by noticing which resource manager each transaction participant is using, and try to cut down the number of branches if possible. So what I mentioned before about this resource manager proxy approach, in the standard XA world, shown over here on the left, the initiator calls the transaction manager to demarcate the transaction. So to begin it and then to either commit it or roll it back. It then makes some application calls. It may call some other other microservices. Those then in turn do their updates to the resource manager. And then finally, when the initiator says to commit or roll back, it calls the transaction manager. Transaction manager then calls back to the resource manager directly to be able to do the commit or rollback calls. Now, the problem with this is that the transaction manager now needs to have libraries and credentials and all the rest of that stuff to be able to talk to each resource manager. If you're talking about tens or hundreds of microservices using a variety of different resource managers, that places an incredible burden on the transaction manager. It makes it basically unmanageable. So what we do in the case of MicroTx is we proxy those requests to the resource manager back through the microservice itself. So when the transaction manager asks to prepare, commit, or roll back, instead of calling the resource manager directly, it calls into our library, and our library then proxies those requests to the resource manager. This makes the transaction manager then completely RM agnostic. So we can support virtually any resource manager with XA support simply by providing the RM proxy code in our client libraries. So we also support Sagas. In the case we're supporting microprofile long-running actions. This is handled in the Java world using a set of annotations. So you annotate your code to indicate that an LRA should be present or should be started, and also then to be able to indicate what functions should be called in your Java code to be able to compensate or complete, to be able to get things like the status or forget it. The long-running action. So those are all handled through annotations, and we have equivalent set of annotations and library calls for TypeScript. For the try, confirm, cancel, it's a similar set of APIs. The biggest difference with try, confirm, cancel is it's based upon the HTTP verbs. So the try phase is done through post requests. When the posts are successful and all the tries have been completed, then the initiator says to either confirm or to cancel. To confirm, we simply use put requests, which are idempotent, so we could retry those if necessary. And same for canceling, we use delete verbs to be able to delete the reservation. And again, those are idempotent requests. So let's talk a little bit about how this will simplify application development. The biggest thing is that there's no change to your development process, and very little change is necessary to your applications. By using annotations, you can make it very clear in your code what your application code is doing, how it's participating in the transaction, what roles it's performing in that transaction. And as well, then, as I say, we provide these interceptors and filters, and I'll explain a little bit more about those in a second. But those help then simplify the use of this. So instead of the application code having to deal with creating the appropriate headers that we use and doing the appropriate API calls, we simply provide a set of library calls that hide all that under the covers. So it hides the details of the communication, and it also then provides the communication between the transaction coordinator and the microservices, and between the microservices themselves. So there's very, very few steps that are necessary to be able to make use of this. And as I say, that makes it much simpler for an application developer to acquire and use this. As I mentioned about interceptors, so this is one of the nicest features that we provide in MicroTx. And what it does is it basically intercepts the requests that are made and the responses that are received in your application code. So the application code here would make a REST request from the initiator, and then our library provides these interceptors that actually intercept the calls and add our transaction headers to those calls. So when the request leaves the initiator, it's not only got the application request, but it also has our transaction headers. When the participant receives that, again, our interceptors intercept the incoming request, and we use the transaction information in the headers to automatically enlist the participant in the transaction. So there's no work that needs to be done on the application code here to worry about the transaction management. Then request then is delivered to the application code. The application code does whatever it's going to do, and then it's going to generate a REST reply. We then potentially add additional headers or update the headers that are in that reply, and then send that back to the initiator. The initiator then interprets those headers, which may be a list of URIs that were reserved, or other information that the transaction coordinator may need. And then finally, that reply goes back to the REST client. So the application code just does its normal request and receive the request, and normal reply and receive those replies. And then our interceptors here take care of all the transaction management and propagation. So with that, I'm going to turn this over to Brajesh, who's going to explain a little bit more about some samples that we provide with this and give a demo of those samples.
All right. Let's take a look at the teller sample application that creates an exit transaction coordinated by the MicroTx transaction coordinator. In this application, there is a teller service in an organization that is responsible for transferring amounts from one department to another by creating an exit transaction. There are three microservices, as you can see: the teller, the department 1, and department 2. Both the department 1 and department 2 are using separate Oracle databases, which are two ATP instances running in the Oracle Cloud in this case. So let me explain the process of an amount transfer that creates an exit transaction. The client makes a REST call to the teller microservice. The teller service provides a transfer operation that can perform withdraw and deposit operations on accounts as an atomic operation. The teller service begins an exit transaction by calling on an instance of the MicroTx library provided TRM user transaction, and that internally calls begin on the transaction coordinator. The teller service then calls the withdraw service in department 1 and deposit on department 2. The MicroTx library in these participant microservices provides the functionality to enlist in the exit transaction. Now, assuming both calls succeeded, the teller service then calls commit on the MicroTx transaction coordinator to commit the transaction. The coordinator then calls back all the participants via the included MicroTx client library to prepare all the participants. Once all the participants are prepared, the transaction coordinator then calls back to all the participants to commit the transaction branches. So finally, the transaction coordinator returns success or failure to the initiator's request to commit the transaction. So now let's investigate some example code to see that very minimal changes are required to use the MicroTx library in an application code. So the first, we'll take a look at the XA initiator application. In an exit transaction, there is this initiator application that initiates the exit transaction, and an initiator microservice needs to only create the transaction boundaries by creating an instance of the TRM user transaction. The transaction begin method here starts a new exit transaction, which can be committed or rolled back by calling rollback or commit. Rollback or commit on the transaction object. Now let's take a look at the participant application side. So the first step in the participant application is to initialize the MicroTx library by providing an XA compliant data source, usually a database that you can see in the highlighted portion of the code here. And then the second step here is shown here. The MicroTx library creates an XA connection to the provided data source in the first step, and then injects this connection into the application code. And the injected connection must be used to execute DML queries that you can see in the highlighted code there. So we have the annotation TRM SQL connection. So that is used to inject the connection, and the same connection is being used to run this statement here. Now let's demonstrate the teller application by making an amount transfer here. So in this case, we'll make a transfer from department 1 to department 2. And the transfer will happen from an account 1 in department 1 to account 2 in department 2. So let's check the balances in these two accounts before we make the transfer. So you can see the balance in account 1 is 10830. So the department 2, account 2 has a balance of 2060. So now we initiate a transaction, a transfer. You can see here in the payload, I'm trying to transfer an amount of 20 from account 1 to account 2. So let's go ahead and make this transfer. So there are no errors. So the transaction was successful. We can confirm this by checking the balances. So in department 1, account 1, the balance has been reduced by 20. So there was a withdrawal. The department 2, the account 2, the balance has increased by 20. There was a deposit in this account. So this is how we can see that the exit transaction was successful. We can see this on a KRE dashboard as well. As you can see here, when we sent the initial request to the teller service to make a transfer, the teller service then started a new transaction by calling begin on the transaction coordinator here. And then it got back a transaction ID using which the teller service made a request to withdraw from department 1, and then request to deposit it to department 2. Then here, the library, that MicroTx library, intercepted this request and made a call to the transaction manager to enlist this participant in this exit transaction. The same happened with in department 2 as well. When both this withdraw and deposit calls were successful, then the teller issued a commit call to the transaction coordinator. The transaction coordinator made a prepare call first to department 1 and department 2. And when the prepare was successful, then the transaction coordinator made commit calls to both these departments. So that actually committed the whole transaction. So this is how the flow looks like in the case of a successful exit transaction. So now let's have a look at a transaction in which there is a failure and the transaction is rolled back. So we'll try to induce a failure by transferring an amount to a non-existent account. So in department 2, let's try to deposit into an account that does not exist. So let's say we tried to take a look at account 7. So you can see that the account 7, when I try to make a request to account 7, I got a 404. The account 7 does not exist. So we'll try to make a transfer into this account and see that the transaction will be rolled back. So this is a transfer. This is a deposit into account 7. So I make a transfer request. So the transfer request must have actually failed. We can confirm this by looking at the balances again. So take a look at the account 1 balance in department 1. So the balance is still 10810, which was here after the previous transaction. So that has not changed. And then the account 7 does not exist. So the withdrawal was rolled back. So this can be seen in the KRE dashboard as well. Let's have a look. So now you see here that the deposit into department 2 failed, which is indicated in red here, and that actually rolled back the whole transaction. So that was about the XA sample application. Now let's take a look at the trip booking sample application that creates an LRA transaction that is coordinated by the MicroTx LRA coordinator. In this application, there are 3 microservices for booking a trip, which includes a flight and a hotel booking. The trip manager and the hotel service have been implemented using the Helidon framework that provides an LRA client which conforms to the Eclipse microprofile LRA specifications. The flight service is a Node.js application in which the MicroTx library provides the required configuration and the LRA client implementation to coordinate with the LRA coordinator. The trip manager service is the leading service where the LRA is started, and it calls flight and hotel services for booking. All services communicate with each other using REST endpoints. Without the MicroTx LRA coordinator, the trip manager service would have to implement the coordination logic to confirm and cancel the booking with the hotel and flight services. So this would require the trip manager to know the confirm and cancel APIs for each participant service beforehand. So in general, this requirement will multiply when many participants are involved in a transaction. And then the complexity to implement a robust and resilient solution will only increase. So the MicroTx LRA coordinator solves these problems. So now let's take a look at the sample code for a LRA participant. So in the case of LRA participant microservices in Java, the LRA annotations as defined in the Eclipse microprofile LRA specifications must be used. The participant application annotates JAX-RS resource method with the LRA annotation, which determines whether the method will run in the context of an LRA. The participant application should also provide other methods annotated with the complete and compensate annotations. So these methods will be invoked when the LRA is subsequently closed or canceled. So this is what is required on a participant application for LRA. So now coming to the transactional security, how do we ensure the transactional security with MicroTx? So to ensure the transactional security, the functionalities that are provided by the transaction coordinator can be used alongside some of the service mesh functionality. For example, mutual TLS that is provided by a service mesh can be used for all traffic between the microservices and the transaction coordinator. Likewise, JWT tokens can be used for user authentication. This has been tested with some widely used identity providers like IDCS and identity domain in OCI and Microsoft Active Directory and Keycloak. The transaction token provided by the transaction coordinator can be used for user authorization. And then some credentials like usernames and passwords can be shared using Docker or Kubernetes secrets. So using these measures, we can ensure the transaction security with MicroTx. So that's all I have from my side. So I'd like to turn it over to Todd.
So let's talk a little bit about how you can deploy this and interoperability. So as mentioned before, we've tried to make this as simple as possible to use. So currently we're supporting Java and TypeScript. We have plans to support other languages such as Python, Go, .NET environments. And as well as you can support a variety of different application development frameworks. So we support Springboot, not Springboot, but Springboot, Helidon microprofile, or WebLogic server. We should be able to support pretty much any environment that provides, RESTful applications using Jersey or JAX-RS. We need sort of those environments to be able to provide the filters or interceptors that we provide. And then as well as I mentioned for TypeScript, we're supporting Express.js using either Fetch or Axios for the REST APIs. Deployment of the transaction coordinator, as Sid mentioned about earlier, it's simply a microservice. So it's runs in a container, and the container can be deployed in a variety of environments. We're primarily focusing right now on operating in Kubernetes and Docker Swarm, which should be able to run pretty much anywhere where we have an overlay network. So the microservices are addressable, and typically there's going to be an ingress and egress gateways for going in and out for access from other services. The big thing about resource managers is that for XA, we obviously need an XA compliant resource manager. In the case of for Java, we need a JDBC driver that implements the XA data source and XA resource interfaces. We have tested this with Oracle Database, PostgreSQL, and MySQL. So we've certified that those work just fine with our XA implementation. Should work with others as well. So Microsoft SQL Server, IBM DB2. Again, it's in the Java world, as long as there's a JDBC driver for support that supports XA. For Node, we need an XA compliant database driver. Unfortunately, in the Node world or JavaScript world, there's no equivalent standard to JDBC and XA data source. So we have our own set of libraries and our own set of implementations for the equivalent of what's done in the Java world, but we provide those in TypeScript to run inside of Node. And we're using the Oracle Node DB driver, but that's what we've certified against so far. Something else, as mentioned before, about this logging last resource. This allows you to include one non-XA resource manager in your XA transaction. So you can use things like MongoDB or other systems where you might not be able to include them in a normal XA transaction without this support. For the long-running actions and try, confirm, cancel protocols, pretty much any resource manager can be used because the transaction coordinator doesn't even know about the resource managers in those cases. So a little bit about transaction interoperability. We support running an existing environment. So we're assuming you're going to deploy into Kubernetes, talking to various data stores. And as well, in the Java world, we provide for the Oracle blockchain platform, we provide a XA resource there. So Oracle blockchain platform transactions can be included as part of an XA global transaction. As I mentioned, these services that you call will automatically get enlisted and they become part of the same global transaction. You can also support Tuxedo services that are written in C, C++, or COBOL using what we call SALT. That's the web services or REST gateway for Tuxedo. So your existing Tuxedo applications can be included in your global transactions. We also are supporting and providing a set of PL SQL libraries to allow ORDS and Apex apps to be able to be included as well and to be able to be participants in an XA transaction. So a little bit more about the architecture. So we've got client applications off on the left or other microservices. They would be connecting to and making service requests to your polyglot applications running in Kubernetes, including things as I mentioned, like the PL SQL with the ORDS and Apex. The coordinator itself runs as a microservice. We are planning on providing a console to be able to monitor and manage the coordinator. And as well, then the stuff sits on top of the other features of such as OCI, so for the Oracle database or blockchain platforms or other resources. Because it runs inside of Kubernetes, we can make use of all the Kubernetes tools for logging, for observation. So we support, using Prometheus, Kiali, ELK, EFK, or Jaeger. So how do you get started with this? So it's available now. Let's say it's called Transaction Manager for Microservices Free. It's intended right now for developers to get started with this and to be able to try this product out. It is free. It's 100% free. There's no licensing costs whatsoever. And if you have an active support contract for various Oracle products, it will provide support for MicroTx under those support contracts. We're trying to make it as easy to get started as possible. So we provide a quick start guide. This even goes so far as providing a run me script, which will run our various samples for you with just answering a few questions. It'll take care of deploying to your Kubernetes cluster or to using Minikube. And the idea behind this is to be able to let you try our sample applications and understand how MicroTx works and what the impact would be on your application. So what do you have to change in your applications to make them transactional? And as I say, the quick start guide will get you through running all 3 different transaction protocols. We provide a variety of sample apps, for each of the various protocols and in a variety of languages as well. So we've probably got samples. The source code for the samples is obviously provided. We provide, some of the use cases. For example, for XA, we provide a money transfer application. For long-running actions, we provide a trip booking application. And for try, confirm, cancel, we provide a travel-based application. A little bit about, when to use distributed transactions. A lot of times I think this gets neglected. And so you end up with unhappy customers, as Deepak mentioned, because you end up with data inconsistency across your microservices. So the fundamental time you need it is when we have what you call a dual write. So when you need to update, more than one source of data atomically as part of a transaction. So XA is oftentimes considered an anti-pattern. But I would contend that for many applications, especially financial applications, XA provides the kind of consistency that you want. Also, in terms of for messaging applications, where you may receive a message, you may then update a database, maybe send another message, or receive a message and send a message. Those all need to be atomic. If your messaging system supports XA, you can do this then across messaging systems, or again, across the messaging system database. For long-running actions and try, confirm, cancel, these are used where maybe XA is not appropriate. This would be especially the case for things that are like long-running actions, where you're taking input from a user or something like that. So that might be order entry. It might be doing something like a multi-leg travel reservation, like we do in our samples. Online stores as well. So filling a shopping cart and then submitting that shopping cart and getting payment made. All those various steps would be suitable use cases for long-running actions or potentially try, confirm, cancel. A little bit about some best practices. The key thing here is to choose the protocol, the right protocol for the consistency that you need for your particular applications. So if you need a strong consistency, like for financial transactions, XA is the obvious use case. Some things about XA, though, is you need to avoid things like hotspots, because during the execution of an XA transaction, the resource manager will have locks being held, typically on rows in a database or messages in a queue. And that can get a hotspot and serialization issues if you're not careful about the design of your resource manager use. So, how your tables are designed and how your application makes use of those tables and the rows. Also for XA, you want to try to keep these as short as possible due to the locking and potential serialization issues. And as well, it's ideal to try to minimize the number of participants. You probably don't want an XA transaction with 10 participants. That's just not probably a very good use case. If you can also then, as I mentioned before, using last logging resource or last logging resource, less resource committer, that's another optimization. And that allows you then again to just be able to support a single non-XA resource in your XA transaction. For long-running actions or TCC, these are things that they're long-running or they maybe span user input. For TCC, it's sort of a two-phase protocol. When you do the try phase, you make all of your business checks and everything else, and you then provide a URI that provides the reservation that you received. And then the confirm phase actually executes any business logic to confirm that reservation. In the case of cancel, it's just a matter of deleting the reservation. The key part here is that the confirm and cancel, they must be idempotent so we can retry those requests. And that's why we use the put and delete verbs for those. For LRA, compensation is maybe difficult, or in some cases, maybe completely impossible. The example might be that, let's say you, as part of the initial execution of your long-running action, you added something to inventory. Maybe you've got a supply of new materials and you add that to inventory. If something should fail and you need to compensate that, then you need to remove that from inventory. Well, if that inventory's already been removed, what are you going to do? You don't have the inventory to remove at that point. So you end up with, potentially some difficult use cases. But it is a useful model for a variety of different use cases. In both TCC and LRA, it's really critical, though, that you provide timeouts. Timeouts are one of the key recovery mechanisms that's used in TCC and LRA. And for all the models, you have to account for heuristic outcomes. These are where things happen, like as I mentioned before, like you go to withdraw from the inventory to compensate, and there's no inventory there. That's a heuristic outcome because there's nothing you can do at that point other than take some sort of extraordinary action to be able to correct the state of the system. And with that, some resources here to get started. So as mentioned, we have the quick start guide. There's a data sheet. There's a series of blog articles that I'm continuing to add to. There's also a white paper about distributed transactions in microservices world. We have a live lab available. There are YouTube videos, and there's also community support available. So to get started, you can go to the oracle.com database transaction manager for microservices, or you can simply use the QR code here.
And with that, I'll go ahead and end today's session. Have a great day, and we'll see you again next time.